We hear about AI literally every single day, but have you ever really stopped to wonder how it's, well, built? I promise you, it's not magic and it's not some big mystery. So let's pull back the curtain and take a look at the actual blueprint.
So how do you actually build one of these things? It has way less to do with robots in sci-fi movies and a whole lot more to do with some really smart, real-world engineering. And here's the secret, right? There's no single aha moment where a machine just magically becomes smart. Nope. Building AI is a structured, totally repeatable process. It's a development life cycle, less like waving a magic wand, and a whole lot more like following a detailed blueprint. And this is that blueprint. We're going to start with the foundation, which is all about the data. Then we'll fire up the engine with training and testing. After that, we'll launch it into the wild and see how it evolves into what is essentially a living system. Ready? Let's get into it. Okay, first up, the AI blueprint. Just think of this as the master plan, the overall strategy. AI projects can get super complex, so having a life cycle like this gives us a structured path to follow, making sure no critical steps get missed.
So here they are, the 5 core phases. You start with data collection and prep, then you do the model training, then you evaluate and test it, then you deploy it, and finally, you monitor and improve it. But look closely at the arrows. This is not a straight line, right? It's a continuous loop. And honestly, that's the key takeaway here. AI development is a cycle of constant learning and improving. Okay, let's dive into phase 1, the data. I can't stress this enough. Data is the fuel for any AI. Everything, and I mean everything, that comes next is built right on top of this foundation.
There's this classic saying in tech that is more true for AI than almost anything else. Garbage in, garbage out. Seriously, imagine you're training a self-driving car, but you only show it pictures of sunny days in California. What happens the first time it sees a snowy road in Colorado? It's going to be totally lost. That, right there, is garbage in, garbage out. Most of the data we find out in the world starts out messy. It's just full of errors, duplicates, weird inconsistencies. Our job is to get it to a clean state, consistent, complete, and perfectly labeled. One of these paths leads to a flawed AI, and the other leads to one we can actually trust.
So, how do you get from that messy pile to clean, usable data? Well, it's kind of like a chef prepping their ingredients before they start cooking. You have to remove the duplicates, fix the errors, and, this is absolutely crucial, you have to label the data. This is how you literally teach the AI, telling it, this picture is a cat, and this one over here is a dog.
Okay, with our squeaky clean data ready to go, we can head to the engine room. Training and testing. This is where the model just churns through all that data, hunting for patterns. Think of it like a student cramming with flashcards. It makes a guess, checks the answer, and then adjusts its thinking over and over, thousands, sometimes millions of times, to get better. But there's a really common trap here, and it's called overfitting. This is what happens when the model gets a little too good at its training data. It basically just memorizes the answers instead of learning the actual concepts. So yeah, it'll get a perfect score on questions it's seen before, but it's going to completely bomb the test when it sees new information. And that is precisely why testing is so incredibly important. It's like giving the AI a practice exam. We use a fresh set of data it's never seen before to check if the model can actually generalize what it learned to new situations. We're looking for real understanding, not just rote memorization. But listen, a high accuracy score can be really misleading. A model can be, say, 95% accurate overall, but still be totally unreliable and biased. It might be 98% accurate for one group of users, but only 70% for another. This is why testing has to go way beyond just one number. It has to make sure the AI works fairly for everyone. So, once a model has been trained, and we've tested it like crazy for both accuracy and fairness, it's finally time for the launch. This is the deployment phase, where we take our AI out of the cozy, controlled lab environment and release it into the wild. But the real world is messy. It's totally unpredictable. A model that was the star student in the clean, perfect lab can suddenly stumble when it's faced with the chaos of reality. Out there, the AI faces all sorts of new challenges. Incomplete data it's never seen, real users who expect lightning-fast responses, and a ton of technical hurdles just to fit into the systems we already use. It's the ultimate stress test, for sure. And that brings us to our final phase, which you could argue is the most important one:
evolution. See, launch day isn't the finish line, it's the starting gun. From this point on, the AI has to be constantly monitored and improved just to stay effective. A huge challenge here is something called model drift. Just think about it. The world is always changing, right? An AI trained on data from 2020 isn't going to understand the slang or trends of 2024. As the real world drifts away from its original training data, the model's performance starts to sink. So how do you fight model drift? Well, you put it in this continuous improvement loop. You're always monitoring the AI's performance, you detect when it's starting to drift, you retrain it with fresh new data, you validate that the changes actually worked, and then you redeploy the better, smarter version. This cycle is what keeps an AI relevant and useful long-term. So let's bring this all together. If there's one thing to take away from all this, it's that an AI isn't a product you just build once and then forget about. It's a living system. At the end of the day, AI development is just a continuous cycle of learning, testing, and improving. It's less like building a bridge, a project with a clear end, and way more like tending a garden that needs constant care and attention to really thrive. That blueprint we just walked through, it isn't for a finished object you put on a shelf. It's for a system that is designed from its very core to constantly learn, adapt, and evolve right alongside our changing world. And that leaves us with a pretty fascinating question to chew on. If an AI is always evolving based on the new data it sees, who's ultimately responsible for what it becomes?
Did you find this helpful? Please comment, like, or subscribe.